Hey guys, next topic superposition theorem. So this is one of the very important theorem, and first of all see the what is the theorem says. So you will be asking question like that: explain superposition theorem or state the superposition theorem. Okay, so first of all see the definition of the superposition theorem. Superposition theorem states that in any linear network containing two or more sources, the response in any element, response means the voltage or current, is equal to the algebraic sum of the responses caused by an individual sources acting alone. So this is the definition of the superposition theorem. So let us take one circuit. So if you solve the one problem, then you will understand perfectly. And once again I'll repeat, the superposition theorem states that in any linear network containing two or more, so the network should contain two or more voltage sources or current sources, whatever it may be, or combination also. For example, this is the circuit. So this circuit consisting more than two voltage sources. So minimum you should have two, or maximum that's up to, okay, any number. So now, according to the statement of the superposition theorem, these circuits consisting of V1 voltage source and V2 voltage source in such a way that, so the two are connected like this. There's a positive and negative. So the theorem is saying two or more voltage sources are current sources. Then the response in any element means what? The response in any element, 2 ohm, the 10 ohm resistance or 20 ohm resistance or 30 ohm resistances. The response in any element is equal to the algebraic sum of the responses caused by an individual voltage source acting alone. So it means only one source should act. So you have to calculate the how much current is coming from this voltage source when this source is should not act. Acting alone means only one source should act. So you have to cancel the source and find the current from this source only, then calculate how much current is flowing. So this question here in this circuit diagram, for example, this is only take example one. And so here the question is you have to find how much current is flowing 30 ohm resistance. How much current flowing 30 ohm resistance. So this is I30 is equal to how much? This is the current. Okay. So now you have to apply this statement to this circuit and find the I30. So here this is asking how much current is flowing 30 ohm resistance when the two voltage sources are connected. So this is a circuit. So according to the superposition theorem statement, we have a three steps to find this current. Okay. Step one. Step one, short circuit the voltage source. So what we have to do, when you are finding this current from the source one, only one source should act. So an individual source acting alone. So second source should we have to remove. How to remove the voltage source? Suppose the circuit is consisting of voltage source, the short circuit the voltage source. If not, for example, if there is a current source and here or here, when you have the current source, then you have to open circuit the current source. So for time being, in given problem, we have only voltage sources. So in step one, we have to remove the one voltage source. So I removed here. So second, this V2 I have removed. How to remove? And voltage source must be short circuited. Short circuit the voltage source. So I have removed and I have short circuited this spot V2. Then, so in step one, what I did, I have removed this V2. So voltage source should be short circuited. I have short circuit. Then you have to find the response from the V1. That is the step number one. So how to find? Let us see, very simple. So the response coming from the current coming from this source is total current. So the total voltage is given 50 volts and total voltage and total current you will get. So first, before that, you have to find total resistance. So for that, total current is equal to total voltage divided by total resistance. So in this case, you have to see we are coming from like this. Okay, total current is coming from like this, and here there is a node. Node, what happens? Current will gets divided. So at this node, so we have to current gets divided. So first of all, you have to find total current. So these two are in parallel. So when you are coming like this, current divide. Here current is dividing. So therefore, these two are parallel, nothing but total resistance is equal to product of the two resistance divided by sum of the two resistances. Therefore, 20 ohms is parallel to 30 ohm, that is equal to 20 into 30 divided by 20 plus 30. Therefore, 20 into 30 is 600 divided by 50. So 0 can cancel. So 60 by 5 nothing but 12 ohm. 12 ohm resistance. These resultant resistance, the parallel resistance, total resistance is equal to 12 ohms. So again, we have to replace the circuit. So therefore, so this will be the 12 ohm resistance, and this V1 is equal to 50 volts. So it's coming. So this 12 volts is again in series with the 10 ohms. So what is this? Is the resistance, right? So this resultant resistance is 12 volts again connected to 10 ohm resistance. Therefore, the 12 and 10 both are in series. So 10 ohm resistance in series with the 12 ohm resistance. Therefore, total resistance is equal to 10 plus 12. Series simply we should add. So 22 ohms is the total resistance. Then we know the total current. Total current is equal to total voltage divided by total resistance. What is the total voltage? 50 volts. Okay. Total resistance 22 ohms. So 50 by 22 is equal to 2.272 amperes. So this will be the your total current. Total current which is coming from the source 1 when acting source 1 alone. So this is the source 1 current. Now we have to find from this total current how much current is flowing through only 30 ohm resistance. So here current is getting divided. So this total current is getting divided. So now here we have to apply current divide rule because current is dividing. We have to apply current divide rule. It's very shortcut formula. By using current divide rule, CDR, current I1 is equal to I1 nothing but I'm assuming this I1 current is flowing. So when source V1 is acting, only single source acting alone, the current flowing through the 30 ohm resistance, I am assumed that I1 current, that is I1 current. This current is equal to, I1 current is equal to the formula total current nothing but this coming from the source into opposite resistance divided by opposite branch resistance plus current branch resistance. Opposite branch resistance nothing but what? So this is the current is coming like this, and to this what is the opposite resistance? 20 ohms is the opposite resistance. So wherever you are finding the current in the branch, so that to that opposite resistance. So this is we are finding the current here. So to this branch, what is the opposite branch? This is the opposite branch. Therefore, opposite resistance branch divided by opposite resistance plus current resistance, nothing but this one. So therefore, so your I1 current is equal to opposite branch resistance divided by opposite branch resistance plus current branch. Opposite branch 20 ohms divided by 20 plus 30 into total current. So total current into 20 by 30. So 20 plus 30, 50. So you will get 0.908 amperes. This will be the current. So 0.908 amperes is flowing. It's a downwards direction. Why it is a downward direction? Because the current is coming like this. So this is positive to negative is flowing. So among this 20 total current, only I1 current is flowing. That is 0.908 amperes is flowing out of what is total current? 2.27 amperes. So 2.27 amperes, only 0.908 amperes is flowing when individual acting source. Here only one source is acting, right? Second source is short circuited. So this is the step number one. So step number one, remove the voltage source and find the how much current is coming from the source one acting alone. So from this source, my I1 current is 0.90 amperes only current is flowing. Next, step 2. Similarly, what we have to do? Similarly, step 2, we have to apply the step 2. So now we have to find the response from V2. So now what you have to do? Step 2. Now we have to close the short circuit to the V1. Short circuit to the V1. So where is the V1? So this will be the V1, right? And this will be the V1. Now we have to remove this source and connect this source V2 and again find the response. Similarly, same procedure. So now what I am doing, I have closed this V1. Okay, so V1 is short circuited. V1 is equal to short circuit. So now acting V2 alone. When V2 is acting alone, then what is the response? Again, same procedure. So this is two resistance are again current is coming like this, and let us say this is the total current, and some current is flowing like this. So from source to I'm assuming the I2 current. From the total current, what is the current flowing 30 ohm resistance? I2. So here current is dividing. Till this point total current is coming, here dividing. So when V2 is acting alone, the current flowing through 30 ohm resistance is I2, I'm assuming. So we have to find the I2. So before that, we have to find total resistance, total current. So how to find the total current? Again, total current. These two are in parallel. 10, because here whenever current is dividing, then you should consider these two are parallel. So 10, 30 are parallel. Therefore, 10 into 30 by 10 plus 30. 300 by 40, this 7.5 ohms. Again, this 7.5 ohms, the resultant of these two 7.5 ohms, and redraw the circuit diagram. 7.5 is 20 ohms. So here is 20 ohms. This current, total current is coming. So total current is equal to total voltage divided by total resistance. The 7.5 plus 20 both are connected in series. Therefore, total resistance is equal to 7.5 plus 20. 27.5 total resistance of the circuit. Again, I draw the circuit. This is the single circuit. Therefore, the total current is equal to total voltage divided by total resistance. Total voltage 20 divided by 27.5 total resistance. Therefore, 0.727 amperes is total current. Again, you have to find the current divide rule and find the I2, how much current is flowing. Therefore, I2 is equal to, what's the current divide rule? Total current into opposite branch resistance. So here, when current is coming, what is the opposite branch to this one? 10 is the opposite branch. So opposite branch resistance divided by opposite branch resistance plus current branch. Nothing but this one. So 10 by 10 plus this 30. So that is the current division rule in second case. So therefore, total current into 0.727 amperes into opposite branch 10 by 10 plus 30. Therefore, 10 by 40 is 1 by 4. So 0.181 amperes. This is the I2. So after getting this I1 and I2, so we have to apply last step, step 3. I30 nothing but current flowing through the 30 ohms resistance. Current flowing through the 30 ohm resistance. This is. So this is the. So from this one, this original circuit diagram. So current I2 is coming from this I1 is coming. Okay. So this is I1 plus I2. I1 from the source V1, I2 from the source V2. So this I1 plus I2 current is flowing through 30 ohm resistance. So therefore, now we have to take I30 is equal to I1 plus I2, 0.908 plus 0.181. So if you have I30 is equal to 1.089 amperes according to the superposition theorem. For example, when any one of this is negative, for example, when you interchange the batteries, okay, for example, this is negative and this is positive, or this negative and positive, then you have to take, so plus or minus, so then I30 is equal to plus or minus i I1 plus I2, whichever is greater. So you will get, you can do sometimes opposite direction plus or minus also. So in this direction, I1 is same direction, I2 also same direction. Therefore, both current can be added. So this is the current flowing through the 30 ohm resistance. So this is the procedure of the superposition theorem to solve the problems. I hope you understand. Thank you.